Welcome class to day 3 of electricity of chapter 2. This section 3, is about series and parallel circuits. How are they similar, how are they different, and how are they used? First of all, what is a series circuit? In this type of circuit, all the parts are connected together one after another. So the light bulb on page 65, each light bulb is connected to each other, and then only two ends are connected to the battery or the voltage source. In a series circuit, there's only one path for the current to take. It can only go in that circle. It's very easy for this one path, but what happens if one of the bulbs burns out? That one bulb no longer can carry the circuit or won't allow the current to go through. So if the current can't go through it, it's going to stop all the others from being lit. We cannot complete the circuit. Therefore, there's no path, so all the bulbs burn out or go out. Also, one negative disadvantage to this type of circuit is that each new bulb becomes somewhat of a dimmer to the added series. So every bulb that you add, if you have one, add another one, each one lowers the current that can go through the circuit. So each bulb becomes a little bit duller, a little bit duller, a little bit duller, and they don't shine as brightly as they would individually. Therefore, all the bulbs will not burn as bright, and the overall resistance increases. Each one of those bulbs becomes a resistor and takes some of that electricity, that electric current. So all of the bulbs become a little bit less bright. And we can check the current with an ammeter as long as it's connected in series right after the voltage source. The next type of current is a parallel current parallel circuit. The different parts of the circuit are connected on different branches. They're connected apart from each other. And that page is on page 66, where there are many different wires connected to those 3 light bulbs. There are several paths for the current to take. It can go through the first loop, the second loop, or the third loop around each of those light bulbs. Because there are several paths, if one light bulb burns out, the other ones can still carry the current, and then the circuit will still be complete. And you can put switches on each one of those light bulbs and control it individually. You can turn off the middle one, turn off the last one without affecting the other light bulbs. As you add branches, you add more bulbs, you're actually going to decrease the amount of resistance overall. So let's think about this. If we have water coming from one source that's only allowed to flow through one pipe, this one is water's just only going through one place. If you have that same water source that can now go through 2 pipes, you're going to have twice the amount of water coming through your pipes. Therefore, the same thing happens. As you add more branches, you're adding more paths for the current to take. Therefore, the overall resistance is less because there are more choices for that current to take. And as a result, the brightness of all the bulbs does not change. They're all just as bright as if they were there individually. And you can use a voltmeter to check the voltage of this type of circuit. And the voltmeter needs to be wired parallel to the voltage source. Now let's think about, what does your house use? What kind of circuit does your house use? Well, if your house used a series circuit, every time one light bulb went out, the whole house would not be able to carry the circuit or complete the circuit. Therefore, all the bulbs would go out. And you know that's not true. So therefore, all the circuits in your house are parallel. Electricity normally comes into your home through a really big wire called a line. And through those lines, they are very low resistance. They have lots of electrons going through them, but don't resist much. And the voltage in your house is about 120 volts. And then each time you have a light switch, it is controlling one branch of the circuit. So think about how many light switches you have in your house. Each one of those light switches tells you that there's a new circuit in that part of your house. So series circuits, only one path for the light or the current to take. If one light bulb goes out, they're all out. In a parallel circuit, there's many ways for the circuit to complete itself. One light bulb goes out, there are still the other paths that will keep the circuit complete. And your house uses this type of circuit. We'll be working on this hopefully in the lab, in the computer lab or in the science lab, making some circuits, some series and parallel circuits to help you with this. Have a great afternoon.